The Optical Image Profiler from Geoprobe is a simple-to-use direct-push fluorescence detection tool used to map the presence of non-aqueous phase liquid hydrocarbon fuels, oils, and tars in the subsurface. These chemical contaminants are comprised of polyaromatic hydrocarbons, or PAHs, which have a multi-aromatic ring structure. When NAPL levels of these PAHs are subjected to a high-energy light source, they will emit fluorescence. NAPL may be detected as layers, ganglia, or droplets of product in the formation matrix. The OIP probe and logging system produces intuitive logs of NAPL-level petroleum products within the subsurface lithology. Two probe options are available, the OIP-UV and OIP-G. The OIP-UV probe uses a 275 nanometer UV light source. The OIP-G probe uses a 520 nanometer green light source. For OIP-UV, UV light passes through a sapphire window and onto the soil. If NAPL-level fuels or motor oil are present in the soil, the PAHs will absorb the UV light and emit fluorescence. A camera captures images of visible fluorescence, which are then analyzed to determine the number of pixels within the image that display fluorescence, typical of NAPL fuels and oils. For OIP-G, green light passes through a sapphire window and onto the soil. If NAPL-level creosote, coal tars, or any heavy fuels or oils are present in the soil, PAHs will absorb the green light and emit fluorescence. An optical filter on the camera excludes any reflected green light from the light source. The orange to red wavelength fluorescence passes through the optical filter, and the camera captures an image of the fluorescence. The captured image is then analyzed by the software to determine the number of pixels within the image that indicate fluorescence typical of heavy NAPL fuels, oils, and tars. The Geoprobe OI-HPT probe combines the OIP system and two additional sensors, electrical conductivity, or EC, and the hydraulic profiling tool, or HPT. The electrical conductivity dipole sensor is used for mapping soil and pore fluid electrical conductance. This gives us an understanding of subsurface lithology. The hydraulic profiling tool uses a downhole pressure sensor to monitor the pressure required to inject a set flow of water out of the HPT screen. The resulting pressure log is directly related to subsurface permeability. Calculations can be performed on this data to determine static water level, estimates of hydraulic conductivity, as well as groundwater-specific conductance where the formation allows. By operating OIP, HPT, and EC sensors together, operators and end users can gain valuable information about their site. Being able to observe the vertical and horizontal extents of petroleum NAPL and the lithology it resides in allows investigators to make well-informed decisions, guiding the site's soil and groundwater sampling, monitoring well placement, and site remediation efforts.
The primary equipment required to operate the Optical Image Profiler, or OIP system, is as follows. We have the HPT controller, which is where the operator will set his flow. It'll record uphole line pressure and downhole HPT pressure from the HPT sensor inside the OIP power supply. The field instrument is where the electrical connectivity circuitry is at. This is outputting the voltage, which is sent down to the dipole, goes through the soil, gets our electrical connectivity values. We also connect our string pot, or depth potentiometer, to the field instrument. That's going to record the depth of the probe as we advance it into the subsurface. And we're collecting the data from all of these instruments and transporting that over to the field laptop via USB cable. The OIP interface outputs power down to the OIP power supply, which will then distribute proper power required by the different components within the OIP probe. Also, if we decide we're going to change light sources within the probe, the operator will set that up on the computer. The interface will send that command down to the power supply, which will change that in the probe. The instruments on the OIP system are connected to the downhole probe that's advancing the subsurface via a trunk line. We have one over here. It's weaved throughout all of the rods.
With equipment set up, QA testing must be done before and after each log to ensure that the equipment is working properly and is generating good data. Testing includes an EC load test, optical test, and HPT reference test. Depth is recorded by connecting a depth potentiometer to the unit. The log is started once the OIP window is even with the ground surface. The probe is advanced at a rate of 2 to 4 feet per minute. Data is collected and viewed in real time through the DI acquisition software. The field instrument collects the electrical conductivity, probe rate, diagnostic parameters, and depth. The optical interface collects the fluorescence images. The field instrument and optical interface send the collected data to the laptop computer. The laptop computer stores and displays the collected data with depth through the DI acquisition software. It also analyzes and stores the fluorescence images and displays the percent fluorescence with depth. A still image can be captured at any depth during a log for each available light source. Still images allow for clear images of the soil and hydrocarbon fluorescence. During the log, the DI acquisition software will automatically capture a still image for each available light source during a rod change. This process is repeated until the predetermined log depth is reached or until refusal is attained. After the logs are complete, operators can open them in the DI Viewer software to review, print, and export the data for modeling. DI Viewer is a free software available on our website for all to use. The HPT-UV log displays the following graphs: electrical conductivity, HPT injection pressure, OIP percent image area fluorescence, depth-specific saved UV images, depth-specific saved visible images, and estimate of hydraulic conductivity. The red dots to the right of the saved images indicate locations of still UV and visible images saved in the file. The OIP-G probe returns a fluorescence image in the orange-red color range as depicted in the analyzed image right column of the log. The red dots are the saved still images, which are taken with the 520 nanometer green LD and an infrared LED. The OIP system produces a detailed log of induced fuel fluorescence with depth. OIP is a simple system to learn and operate, and the interpretation is intuitive and quick. For more information, visit our OIP webpage at geoprobe.com/OIP or call us at 785-825-1842.